Hey everyone, welcome to this ultimate high-yield explainer. Look, if you're feeling the stress of an upcoming C++ exam right now, or maybe a high-stakes placement interview, just take a deep breath. You are in exactly the right place. Today, we're cutting straight through the noise and focusing on the core concepts you absolutely need to know. We're going to give you a brief, highly focused overview so that you can walk into that room and clear your exam with total confidence. So let's get straight to it.
All right, here is our precise roadmap for today. We'll start with building blocks and constants, move right into object-oriented programming, tackle encapsulation and data hiding, jump into constructors and memory management, and finish off with code clarity and readability. Okay, part 1, building blocks and constants. Let's dive right into this. On one hand, we've got standard variables. These are values that can, well, vary. They change during execution to store and manage shifting data. So, for example, if you write int score equals 0, you can update that score constantly as a player progresses in a game. But on the other hand, we have constants, and these are totally locked down. If you write const float pi equals 3.14, the compiler will throw a massive error if you ever try to change it. So think of standard variables as managing the shifting landscape of information, while constants provide these unbreakable anchors in your code.
Now, here's where professors and interviewers love to set formatting traps when you're declaring these constants. Valid integer constants are straightforward, right? 111, -1, 0, or 123. But look closely at the invalid rules. You literally cannot use special symbols. So throwing a $sign before 123? Instant error. You can't use spaces either, so 1 space 23 is just broken code. And commas are strictly forbidden, meaning 1, 112 is a massive trap you have to avoid. Just keep your constants clean, numeric, and simple. Moving on to section 2. Enter object-oriented programming. I actually love this quote from our source material. A class is basically like a blueprint of these objects. It brilliantly illustrates the whole core concept of object-oriented programming. I mean, think of a class as defining how a teacher should look. It dictates that a teacher needs a name, a department, and a salary. But, and this is crucial, the class doesn't actually build the teacher yet. It's really just the architectural drawing sitting there on the developer's desk. So just to formalize that thought a bit, a class is that blueprint, and an object is the real-world entity brought to life in your code. Imagine a software factory. Once that factory has the class blueprint, it can generate 100,000 unique teacher objects, teacher 1, teacher 2, teacher 3, without you ever having to rewrite the underlying logic for what actually makes a teacher. It's the ultimate strategy for code reusability.
All right, section 3, encapsulation and data hiding. Listen up on this one, because it's a massive exam and placement interview topic. Encapsulation is quite literally the process of taking your data, which we call properties, and your member functions, which we call methods, and packing them securely together into a single cohesive unit. Basically, you're building a protective capsule, which in C++ is your class. But why do we even go through the trouble of making this capsule? 2 words: data hiding. We have public access, which means data and methods are accessible from anywhere in your code. Like a teacher's name is public, it's totally safe to share. But then we have private access, and we use this to hide sensitive data completely from the outside world. If you're coding a bank account class, your balance and your password absolutely must be private. By using that private access modifier, you guarantee that outside functions can't accidentally or maliciously change those values. Nailing this concept really shows your interviewer you understand secure code design.
Okay, on to section 4, constructors and memory management. You really need to focus closely here because inheritance and memory execution contain some of the heaviest interview traps you'll face. Let's start with inheritance execution order. When you create an object of a derived class, what actually happens first? Well, step 1, the base class constructor is called. And then step 2, the derived class constructor is called. So for example, if your student class inherits from a person class, the person constructor runs before the student constructor. Professors and technical interviewers literally love testing this exact sequence, so definitely lock this step-by-step process into your memory right now. Now, what goes up must come down, right? A destructor is a special automatic function, always designated by a little tilde symbol, that deallocates memory when an object is no longer needed. And here is a massive warning for your exam. If you use the new keyword to allocate dynamic memory in the heap for an object, you absolutely must use the delete keyword in your destructor. If you don't clean up that dynamic memory, you create a memory leak. And trust me, that is a very fast way to lose points. And that brilliantly illustrates our next major trap: shallow versus deep copying. A shallow copy simply copies values and memory addresses. What that means is if you copy object A to object B, both of their pointers are looking at the exact same heap memory. Our source materials shared a hilarious but painful anecdote about this. A programmer made a shallow copy of a student named Rahul to create a new student named Neha. Well, when they updated Neha's GPA, it accidentally overwrote Rahul's GPA too. Why? Because they shared the same memory address. To fix this, you have to write a deep copy constructor, which allocates brand new, completely separate memory in the heap for that copied object.
All right, the final stretch. Section 5, code clarity and readability.
Look, passing an exam or an interview isn't just about writing code that barely compiles. It's about writing code that is clean and understandable. Let me pose a question to you. What happens when your constructor parameter names exactly match your object properties? Say your teacher class has a property called department, and your constructor takes a parameter that is also called department. How does the C++ compiler actually know which is which? Left to its own devices, it gets completely confused by the overlap. Now, a lazy coder might just name the parameter D to avoid the whole issue, but you really shouldn't do that. You should always use descriptive naming conventions, like department, because it drastically improves overall code readability. This is so vital because in the real world, other developers are going to need to read, debug, and understand your code without you sitting right there to explain it to them. So, to solve that overlap problem, we use the this pointer. Notice how writing this pointer, department equals department, tells the compiler exactly what to do. The this pointer explicitly points to the current object's property, while the plain word just refers to the parameter. Never sacrifice descriptive names for the compiler, just use the this pointer and keep your code beautifully readable. Which brings us to our final thought for today. When you sit down for your exam or you log into that big placement interview, ask yourself, will your code just manage to compile, or will it be beautifully structured, highly readable, and completely leak-free? By mastering the difference between constants and variables, enforcing solid encapsulation, handling deep copies and destructors, and writing clean code with proper naming conventions, you are absolutely setting yourself up for total success. But once you've mastered these foundations, you've got to wonder, how do you handle massive, complex software architecture with thousands of interconnected classes? Keep that question in mind as you take your next steps. Best of luck on your exam. You are absolutely gonna crush it.